By Newton's second law, the final velocity is equal to the initial velocity plus the net forces divided by the mass times delta t. If the net forces are equal to 0, then the final velocity is equal to the initial velocity is a constant. Position will then be a linear function, since the final position is equal to the initial position plus the final velocity times delta t. Let's see a little video where we can see that because the force of gravity is equal to the normal force, the net forces are 0, and the motion therefore is at a constant velocity. That went by really fast, but as you can see in the upper right, because we're moving to the left, the position vector has a negative slope, and it looks quite linear. We can model this with a computer simulation using the assumption that the velocity is constant, and basing it on just the first two measurements, using that as our constant velocity. If we do that, we get the blue graph that you see here, and superimposed on that is the actual data. So the computer simulation, the blue graph, is quite close to the actual data. Near the end, there's a little bit of a gap, and that I think is caused by a little warp in the table, but pretty good agreement with theory.